Okay, welcome students to our unexpected presentation. As you all know, we're in the midst of this coronavirus crisis, so we can't hold our workshop as we would have done. What we're trying to do is to give you as much of the information, data, methods that we would have covered as best as we can. We are recording this using Zoom. You all know me, and maybe some of you have met our research associate. So Dr. Xavier Ferrer is, you can see him on the screen. He is our expert in machine learning, and he's going to cover word embeddings in more detail as well. I think some of you know Dr. Tom Van Noonen, and he has already recorded something to YouTube. We'll get to that in the slides. So since we've got a lot to cover, let's get started. So I think, as you all know, we've set up this module so that we're drawing on active research that we're doing in related projects and trying to share with you kind of tools and methods so that you can utilize some of these both for your assessment and possibly for your dissertation. So this might be something that some of you are doing for your dissertation. We've already covered a little bit last semester bias and discrimination in the Theorizing Big Data class, specifically in week 9. I would advise you all to go back and look over those much more extensive notes if you want more information, if you're going to do this topic from week 9 last semester. For now, we're going to do a quick introduction, and this workshop and the material that we're going to cover also relates to a workshop that we had planned to do at the Science Gallery London this Thursday, but alas, that's been postponed, as most things have been. So anyway, let's get started. So here we are, and we're calling this Genders Calling Out AI. Okay. Sorry, let me just, here we go. Okay, there we go. We just have, so, okay, the first thing is there is a questionnaire. I strongly urge you all to please click on the links on Qualtrics, and you will be able to take the questionnaire yourself. It's only going to take you about 5 minutes. I think it's really worthwhile because I know many of you will want to do this kind of qualitative, quantitative research, interviewing questionnaires. And I think if you do this questionnaire, it'll give you a good experience. And we are going to upload a separate, some separate video covering how to do the questionnaire, how to get ethical approval, and some questions that you want to ask yourself when you are putting together questionnaires and interviews. So by doing the questionnaire yourself, I think you're going to find that helpful. So there'll be more links on that on Keats. Okay. Now this is stuff that we covered last semester. I think, you know, the Compass case, where in the US, their justice system was using an algorithm to try to predict recidivism, that is, whether people that are currently in prison would commit a future crime, and then their parole would be granted or they would stay in jail longer. And we found really quickly that this was deeply biased against people of color. So got extensive slides on that that you can go back and look at, but it's been really well studied, and it's become a kind of a cornerstone to demonstrate bias, algorithmic bias and discrimination. So you can see issues of bias and discrimination. They are plaguing automated decision-making systems for human resources. So for a hiring process, we're seeing it having a negative impact oftentimes in terms of assigning credit worthiness, so whether you can get a loan or a mortgage. And a lot of the literature has been specifically around racial bias. Right, and we covered, for example, at MIT, the researcher there, she has set up the Algorithmic Justice League. I think you've seen that, but if you haven't, I've included a link there, and it's worth taking a look at that. So this is a prominent and a very important area, and it's not surprising insofar as what we're seeing, because as you already know, by the way in which a lot of automated decision-making systems get constructed, they need training data. And so we're just seeing invariably bias that's embedded in society that it's getting reproduced in training data. And also, this is just a moment where we can remember how deeply embedded all technical and data-driven systems are within larger social contexts. And we shouldn't think about kind of technical things as if they're in a bubble and as if they're not embedded into these wider systems. Okay, what we're going to do today and what we're looking at is slightly different, because it's looking not only at gender bias, but the kind of the shifting nature of gender. But let's start just with gender bias. And so here, again, if we're looking to societal norms, we would expect to see that there would be gender bias that was kind of predicated on patriarchy. So in other words, where we would see females having a bias against them in general, right? You can just see a few kind of links here for that. Sometimes these on the surface, these examples seem almost funny, kind of, but not really. So if, for example, Samsung has a virtual personal assistant called Bixby, and if a female says, "Let's talk dirty," then there's a kind of a provocative sort of answer that's somewhat sexualized. Whereas if a male asks that question, then it responses around soil erosion, right? So even just if both were meant to be funny, we can see that the way in which males and females are addressed is fundamentally different. So I think this is a moment, and if we had a workshop and you were in front of us and we didn't need to practice social exclusion, then we could have a discussion around thinking about the ways in which you may have suffered from digital discrimination. So, I mean, those are things maybe that are worth, to whatever degree, discussing amongst yourselves, thinking about incidents where and when you feel that that's happened. It would be really interesting to know among the women in our class if you felt that there's any kinds of gender bias that maybe you've kind of noticed or has been really overt. It would be interesting to sort of think about, because of course, one of the reasons why this research in general is so important is because of the degree to which kind of data generation and its processing and the way that it's made actionable against us is kind of diffused across every aspect of our everyday lives. And it requires us sometimes, you know, we don't necessarily think of these things in a moment, but maybe sometimes we do. So I think that's just something that is worth all of you sort of thinking about, and to whatever degree you can, discussing amongst yourselves, which I know is not easy, but maybe virtually that can happen. So, okay, let's just look at the kind of the definition that we have put around digital discrimination. So we're talking about unfair or unequal treatment of an individual or group that's based on certain characteristics, notably race or gender, and that is caused by automated decisions that are taken by AI-based systems, right? So I think I've talked about this a little bit last semester, but I'll remind you again. So DADD stands for detecting and
testing, digital discrimination.
Digital discrimination, right? So it's funded by the EPSRC, which is the Engineering and Physical Sciences Research Council, a UK research body. It's led by Dr. Jose Suk, who's in the Department of Informatics. I'll show you the team. It's a cross-disciplinary team, but we're trying to explore and improve our understanding of digital discrimination, and we're doing it from a very cross-disciplinary perspective. So it's very relevant to our program in the way that we're trying to be cross-disciplinary. and the way that we cover social and legal and, of course, technical dimensions. Xavier later is going to talk a little bit about some of the more groundbreaking methods that are going to be able to certify whether or not data sets and algorithms discriminate, and this is going to be the automatic verification of computational non-discriminatory norms, and then these can be formalized, and here's where we see the kind of the socioeconomic, the cultural, and the legal, and the ethical dimensions. So we're going to try to draw on many of those here today. Okay. Digital discrimination. So we've covered all of this. So I, again, go back to week 9 slides and you'll have even much more detail. But here is where we're thinking about training data, right? And the importance of the training data, which allows for the algorithms to function effectively and accurately, and the real ongoing challenge of biases that are in training data. So here is a moment, and this is why in other readings last semester we've talked about coded gaze, like what is a coded gaze? And in a sense, this is where we need to think about how we might be represented in training data sets, and in turn, how automated systems learn to see us and to take action on us. So we need to ask what's in that training set. We need to ask what kinds of norms and biases are embedded in classification, because of course classification is fundamental to being able to discriminate, to understand, to generate relations, and map inputs to outputs in any kind of automated decision-making system. And so what we want to try to understand is, when are there disparate impacts, i.e. the impact in an automated decision-making system is uneven across especially identifiable groups, like, for example, race or gender, or even class for that matter, right? So this is what we mean by digital discrimination. You can see, some of us, there's Xavier, there's Tom, me, Jose is here, Natalia, Luca, you can see, and our colleagues from law. This is the team that we have, the research team, and we're about 2 years into our 3-year project. Okay, so let's just look at some definitions here, and we can see we've covered all of this in detail. We know what algorithms are. We know what AI is, right? And I think, and I always talk also about thinking about AI in kind of simple and almost neutral terms as automated decision-making systems, because data is fed into any AI system, and there is some kind of mapping, there's some kind of output that is generated, and it's not necessarily explicitly programmed, so it might discover relations or rules, and then it starts to kind of function in the wild, which is important. And yeah, again, if we look at machine learning, that's about computers learning without being explicitly programmed to do whatever it is that it's doing. And this is, again, where data sets are so important, right? Because this is the time when the machine learning learns to make its decisions, and where it does its modeling, right? So, if we think about, machine vision, right? The way that computers can recognize shapes, or in this example, a kind of a triangle, it's going to be given many examples of that triangles and many examples of images that aren't triangles, and the training will be about improving the mapping of the input to the output. So a square is not a triangle, and triangle is triangle, and they're recognized as such. So, okay, if we go to the origins here, and it's always good to have kind of Venn diagrams, because we can understand how different elements and factors come together, and we see data models, processing power, and big data. So the data is, I mean, that's one of the things that's changing and making it more possible to have the diffusion of automated decision-making systems, is because we generate so much data in our everyday lives, and data sets are much larger. And especially in terms of machine learning, Xavi could talk at length about the way that, machine learning and neural networks, for example, were struggling before because they needed to use kind of toy data sets. And now we have so much data, it's so much easier and more plausible, along with processing power, for that modeling to happen with a much higher level of accuracy and kind of really good results. Again, the data is crucial in all of this, and that training data invariably, may contain different kinds of biases that in turn are going to impact on the kind of the decision-making systems. So, okay, if we're talking about the meaning then of digital discrimination, we're talking about when individuals or groups are treated either unfairly or unethically on the basis of their personal data. And this is where it's really important for us all just to take a moment to step back and to think about how this is a significant problem, because we're constantly generating and having our personal data shared, and that is being factored in decision-making systems, right? Decision-making systems that, by being automated, means that they're not in a moment necessarily subject to human oversight, right? Yet it's going to impact people in their everyday lives, right? So this is part of why this is so important, right? And we, as we'll see, we will be able to distinguish discrimination from bias, right? Because it implies that people are treated differently based on characteristics, right? Whereas a bias can be positive or negative. So a bias becomes, and I don't know if Xavi's going to talk about this, but bias can be used in a technical sense in kind of different ways where it doesn't really relate to humans' characteristics or impacts on humans. But here we're talking about bias becoming discrimination when it's a negative bias that is against a protected population, right? So here we have a kind of a trivial example. An algorithm creates a bias towards people born in April. It will be biased, but it won't be called discrimination, just as an example. So if we think in terms of the process of digital discrimination, right, it happens when data reflects human bias against a protected population. So here's where we see it in a much more serious example of kind of hiring, right? Within all human resources processes are becoming increasingly automated. So we see in terms of who gets hired, or indeed who may be promoted, right? You might see kind of a bias in that sense. Or when data is incomplete. If you remember last semester, we saw a couple of examples where people of color, their faces literally couldn't be recognized. That's why the researcher at MIT started to wear that white mask, because she realized early on that her face just actually wasn't being recognized as a face. And it turns out that had to do with the training data and just the lack of diversity within that training data, right? So now, okay, we're talking about gender, and this is something that is unique to our project. And on the one hand, we know after millennia, not years or centuries, but millennia of patriarchy, we know that there's a kind of a general global discrimination against women across most societies to varying degrees. So Caroline Criado Perez has written about this recently. She talks about the gender data gap, and even just the fact that there's more data collected from men than from women, and how this might also even be a factor, and how it's going to lead as yet another factor for gender discrimination to be reproduced within algorithms. And so I'm here, this goes to the word embedding section. Now, Tom has actually made a special YouTube site. You can see there's a link right here. You can click on it. I bet you never really thought that there would be a YouTube site for this class, but in fact there is. And from here, we're going to, I'm going to skip ahead. No, okay, I'm going to pass it over, and I'm going to, we might have a brief kind of technical challenge here. Xavi, what do I do at this moment?
So you need to stop sharing, and then I share my screen.
So,
then, yeah.
Okay, I've done that.
Okay, now I'm sharing my screen.
Great.
Let's see if it works.
It's still recording. Hopefully you can still see it.
Can you see my screen, Mark?
I can see your screen.
Okay, let me see.
I see your Spanish Zoom.
Yeah. Okay, now I need to present this. Let's go to the slide. Yes. So yeah, so I'm taking over from this point. Yeah, just make sure, please, to take a look at Tom's YouTube video, because it's super important. It's necessary in order for you to understand what we're going to present here.
And even they should look at this before looking at yours. They should look at Tom's before looking at this, right?
Yeah, exactly. So just please
stop. If you haven't looked at Tom's YouTube, stop, please, watch it, then come back to here.
And then, exactly, then come back to this point. So basically,
okay, welcome back, everybody that stopped and watched Tom's video.
Welcome back, everyone. So yeah, so let's keep going on. So basically, Tom's video is super important because it explains why are we using word embeddings and what word embeddings are. So and we're in our application, which I'm going to present next, we're exploiting word embeddings, distances and similarities between words, and this is important in order to understand the results that I'm gonna show you later. So let's talk about gender bias using word embeddings. There are different applications for using word embeddings. I think in Tom's video, he also presents those applications. I'm just gonna go really fast over them. So basically, it's known and it's been studied that some ads, they are like focused, they are what it's called gender biased ads. So basically some ads are more like closer to what we call a male respondent, let's say, or to a female respondent. So this application here, what we have the URL here down here. You can just paste an ad and it will tell you whether it's gender biased towards male or towards female. The way it works is basically checks some words that are often associated with male or female, and it just basically estimates kind of a number that tells you, okay, this is more likely to be biased towards male or towards female. I don't know exactly how it works, but they have a list of words, so that's what I guessed. And they probably used a similar approach in this one, which is called the gender bias decoder. Basically, you paste the text here and they show you which words are often associated with male and female. And then it tries to balance this gender differentiation, let's say, between the text. So at the end, it tells you whether it is male or female biased or whether it's kind of balanced. In our application, we're going a little bit further because this is not giving you a lot of information. So in the context of our project, Discovering and Attesting Digital Discrimination, we created what we call a language bias visualizer. Basically, you can access this language bias visualizer here using this link. I'm gonna go a little bit through it and then I will open the website, so I will guide you through all the different sections of the website. But basically, we prepared this visualization tool trying to following what our paper, it's not yet published, but we created an algorithm to detect using word embeddings whether certain words appear closer to what we call the female concept or the male concept. And this is what we leverage in order to show you the data that you're gonna see in this website. Okay, so basically the language bias visualizer is a tool that lets you interact and compare male and female stereotypes in large textual data sets taken from the internet. As you will see, we have 4 different data sets that have different biases towards female and different biases towards male. And using this tool, you can get a grasp or an idea of what are the conceptual biases found on those data sets. So some of the things that you can see, some of the words that you can find in these data sets, in our application, it's basically, we have a set of words, what we call female bias words on our left. We have a set of words which are like male bias words. And here we're showing kind of a word cloud with the most frequent words biased towards females and males. You can select it. I will show it. I will show it later. But you can see this is for the red pill, which is a really strongly biased, gender biased community. You will see that most of the most frequent gender biased words towards female are words that are related with sexuality or physical appearance or related with sexuality, let's say. While on the other side, for male, it's more related with leadership, power. You will see this, and the interesting part is that you can play with this data, so you can select different data sets and compare how do these data sets compare, right? So this is one of the sections that we have on the website. So how does it work? Again, please take, if you haven't taken a look at Tom's video, please take a look first. Because what we do is basically we load the data set. It needs to be a textual data set. So textual comments from a subreddit, from news, from product reviews, etc., etc. So we load this data set. We train an embedding model, which basically places these words in this high dimensional space in which words that are closer in this high dimensional space mean that they are more similar or they are used similarly in similar context, right? And so trying to exploit these similarities between words, we train what we call our algorithm. We discover gender bias words. So as you can see here, for instance, here we're showing some clusters of concepts, which are aggregations of words that talk about the same, what we decided to be the same concept. And it is clear when you see this picture that there exists a separation between female and male bias words. You can see the male bias words on the bottom right of the figure and the female bias words on the top left. And I will show you now. We consider that female bias words are those words that fall closer to the female concept and farther away from the male concept, and vice versa. So basically male bias words are those that fall closer to the male concept and farther away from female concept. So yeah. We also prepare 4 different data sets because it is also important to understand that the biases that we find in the data are biases from those specific communities. So this is not a general analysis of society, let's say, but we gather data from a specific community, let's say Google News, the red pill, which is a subreddit, the red pill, and then we identify the biases used in that community, right? We prepare 4 different data sets, more general ones. For instance, Google News is basically a data set formed by news. It's a collection of more than 3 million English words collected from the US Google News service. This data set is not supposed to be strongly biased, but as we will see, there exist biases also in like general or like general public news as you can find as the ones you can find in Google News.
Yeah,
on the other hand,
can I just ask, like,
sure, yeah.
So for example, for the Google News data set, you know, ostensibly, given that this is gathered broadly from a host of different news sources, formal news sources in the US, we might expect, or this is a good test for us to kind of think about how language is used in something that many of us might think of as neutral, or certainly what many of us will take for our everyday information.
Yeah, exactly. Definitely, yeah. So as you will see on the other data sets, for instance, on the red pill, there is like a really strong gender bias language, so a really strong language, but you will not find this in Google News, as it's like a more general purpose, let's say, language, the one is used. But nevertheless, biases exist. This is what you're going to find using our application, yes.
Okay.
Which it's interesting, yeah. So that's the first data set. It's supposed to be one of the most neutrals, but as you will see, as we were saying, you can explore the biases and you will find that there are some biases in there. Then we jump to the red pill. Red pill is a community or a forum for the discussion of sexual strategy in a culture increasingly lacking a positive identity for men. So this data set is strongly biased towards males, and it kind of undermines women. You will see the language that they use, and we will see later, but this is a strongly biased data set. We also have another data set called Dating Advice, which is also a subreddit. It's a subreddit community intended for Reddit users to share the favorite tips, ask for advice, and encourage others about anything related with dating. So this is also, again, it's supposed to be neutral kind of data set, not as strong as Google News, not as neutral as Google News, but not as biased as the Red Pill. So kind of in a middle ground, let's say. And finally, we have Gender Critical, which is a data set that describes itself, so it's a community that describes itself as a woman-centered radical feminist subreddit to discuss gender from a critical feminist perspective. So if the Red Pill is biased towards male, we can expect this data set, Gender Critical, to be biased towards woman. So it's also interesting, if we will see later, if you can open two tabs, two Chrome tabs, or and then compare those two data sets, the biases that you find using those two data sets. Because the biases, even if it's biased towards woman or towards male, the biases are really, really different and of different nature. And they're super interesting to see. So yeah, I will now show you our tool, and I will walk you around our tool. So basically, what do algorithms learn about our biases from textual data? Okay, let's go. So this is our website. As Mark was introducing before, this website was created in this project, like Discovering and Testing Digital Discrimination. It's an EPSRC funded project from King's College London. And yeah, and basically here you have a description of what I've been explaining to you already. So basically we're just showing data that we found using our algorithms or our methods to detect biases in word embeddings. And yeah, here we go to the first section, which is the dataset selection. The first thing you need to do here is pick one of the datasets: Red Pill, Gender Critical, Dating Advice, Google News. Those are the datasets that I just described. When you pick one of those, the description is going to change if it loads the website. Yeah, exactly. So here you have a description of Gender Critical, and here, for instance, you have a link onto the dataset, the actual dataset that we use, or the community. In that sense, it's a link to the community Gender Critical. It's interesting that before using our tool, you take a look at the posts in each of those communities, so you can then kind of contextualize the information that you will receive from our tool. It's really interesting that to spend, I don't know, 5-10 minutes. Let's go back to the Red Pill. You will see. The Red Pill is a quarantine subreddit, so we're not giving the Reddit link, but it's the same forum. So take a look at the subreddit, take a look at the data set, and try to figure out what biases do you expect to find in this data set, because that's a good exercise. And then you jump to the analysis of the data.
And again, Xavi, if I can just interject just for a moment.
Definitely.
I agree with Xavi's suggestion that you should take a look at the source, take a few minutes. It's a reminder for all of us that data is gathered from a specific place. And of course, these different data sets have been selected, as Xavi has been outlining, because they represent different kinds of, let's say, belief systems or different kinds of norms. So it's just good to look at that in context before delving into the data set, because it's a reminder that ultimately the majority of social and cultural data that gets processed through different kinds of algorithms, machine learning, AI, invariably comes from social and cultural formations, from the ways that people communicate, and those normative beliefs get invariably embedded in that, and that's one of the basic things that we're trying to get at here.
Exactly. Yeah. Thanks. So yeah, you can interrupt me as many times as you want. I think it's really interesting, your perspective as well, because it's nice when you explain things more clearly. So thanks, Mark.
You're very clear.
Yeah.
I'm just trying to emphasize a few things.
Okay, great. So okay, let's keep going. Once you selected your data set, everything, the whole website is going to change and it's going to load the whole data set. All right. So you select the data set here and then you jump to the section explore the data. This is kind of a summary of what you're going to find on the website. Those are our 6 experiments or our 6 interactive figures that we prepared to explore the data of the data set. So I would let you, I would say just follow like the website. Just the first one is most frequent gender bias words, which is, it's what we saw before. It's a collection of the most biased words towards female and towards male in the selected data set. And not only the most biased words, but also the most frequent among the biased words. So those are words that are both used frequently in this community and used in context, in female related or male related context. So those are like what we call like dangerous words, because it's not something that some user has used once to define a female, but those words are shared by the whole community. So this part is, I would say that it's important. Another thing that I haven't explained is that there are like this show more and show less links in which if you click on top of it, it explains you what can you do in the specific figure. For instance, in this figure, you can select words and they kind of become highlighted, and these highlights can also be seen later in the next figures. I will show you later.
So Xavier, is this the red pill data set that we're looking at right now?
This is the red pill data set, yes.
Okay.
You see here. So yeah, so the words that I'm going to show you are kind of biased and yeah, they're strong words. For instance, as you can see here, for instance, female words, as I was showing also in the presentation, are always or kind of related with physical appearance or even sexual behavior, let's say, condoms, bitchiness, nympho, whatever. And for males, on the other hand, you see Avermensch, vision. I'm not sure if I pronounced that correctly, but it's fine. So strategies, pioneers, grandson. So it's just leadership and powerful words. In that sense.
Not particularly negative connotations for the male.
No, it's not in this data set. So basically, in this data set, it's more like, as I was saying, leadership related words, powerful words, or strong related with the strength. As you will see, I will show you later as well. We can also see Obama, a president, Tesla as a kind of a representation of what is often biased towards male. What is a good, how can I say it? What is a good image of a good, or of a male? Yeah. Yeah, so clicking on this, it will move you to the section, to the actual section. I'm just gonna follow the website and then you can play with it a little bit later, and I will explain every section step by step. So then after this most frequent gender bias words, we go to the detailed dataset word biases, which is basically the information of the dataset, all the information that we have. So we're showing you here, we're showing the bias, the frequency, the sentiment, the part of a speech of each of the words that we selected to be most biased in this data set. We selected the top 300 words, most biased words for each category, female and male. The data sets have many more words, but this is just a threshold that we set up because we thought that it was already interesting and the website otherwise was not working. It was super slow. So that's why we decided to keep only the 300 most biased words. Everything is explained here. So you can just take a look and explore it. And if you have any questions, you can also email us. So basically here we have the tables of all those words that are biased towards female on the left, male on the right. If you click those words, you highlight or remove the highlight. You can see the highlights here as well. You can order the words by clicking those columns. For instance, the bias, for instance, goes from 0 to 1. 1 means super biased, 0 means no bias. So for instance, the most biased word in this data set that was female is chick. That means the frequency, how many times has people in this subreddit used the word chick, right? That's the sentiment. Sentiment goes from negative to positive. goes to -1 from -1 to 1. -1 is negative, 0 is neutral, considered neutral, and 1 is positive. Sentiment was found using, was found using NLTK sentiment analysis library. I'm not sure if you want the details, but I'm just going to explain everything. And then this is the part of speech. Part of speech is whether it tells you whether this word is considered a noun, an adjective, a verb, preposition, and etc. This information was extracted using the NLTK post tagger. So basically, if we order the words, this is interesting, an interesting exercise. If we order the words by the most negative, you will see what. So the set. Okay, let me go again. The sentiment of the words is the polarity that some words carry with them. So some words are basically negative, and some words carry a positive connotation. So this analysis gives you a number of how positive or how negative the connotation of a word is, right? So for instance, if we ordered all the words in the data set, all the female bias words by sentiment, you can find all the most negative bias words, and we can do the same for male. For instance, woman, horse, sluttiest, horse, slut, sluttier, bitchness, cheating, blah, 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 blah. Those are some words that are often biased and negatively, with a negative connotation towards female, while men are more often, like the most negative and biased words towards male are related with killing, faggot, fucker, hated, bullied, motherfucking, and along, etc. So this is also interesting. Another interesting exploration that you can do is ordering the words by frequency. And then you see that which are the words among these 300 most biased words, which are the words that are more frequent in this community, more frequent and biased in this community. So strategist is a word that is often used in male related contexts. And while female, the most frequent and biased words towards female is fagliest, which means if we click on top of it, we will open an Urban Dictionary website. Basically, fugly means fucking ugly. Okay, so we added this Urban Dictionary web link, so people, because they are also using a lot of acronyms, for instance, and abbreviations. So you can click on it, and it will open a new website with an explanation of the word. If we can find it, because sometimes you're gonna find it. Okay, so this table to me is one of the most interesting parts. Although it looks like a lot of data, it actually spends some time exploring the words that you can find here, because it gives you a really good understanding of what are the biases in this specific data set.
And Xavier, if I can just ask you, so for example, for this section where we're getting a lot of detailed information in terms of being able to understand bias within a data set, you're using some other kind of libraries and tools. If you can just slightly scroll up, you talk for the detailed data set, you're using the sentiment analysis library and the POS tagger. So this is something, if I understand correctly, that, for example, if students were doing their project, because everyone's going to do a project in this class and they have a different data set, they can more or less follow this process and generate a similar kind of detailed data set of word bias in their data set using those same libraries.
So what you can, I mean, the code for detecting these biased words specific is not yet published. So this is a problem, but those libraries are public. So if you want to detect the sentiment of a word, you can just click here. That's why I added the links, and it brings you to the sentiment library. This is Python standard languages, natural language toolkit. This NLTK stands for natural language toolkit, and it's a Python library to, I mean, it has a lot of things, but basically here I'm using the sentiment and part of the speech tagger.
Okay.
Once we have this code already accepted, we can just publish on the internet and let other people play with it. For now, that's why we created the visualizers, so people can actually work on our results. Yes.
Perfect.
And also, if you have any question or anything, you can just email us.
We'll just to let the students know, we're going to kind of formalize some kind of virtual Q&A Tom and Xavi and I just have to finalize the details, but that information will be on Cote's, and it'll be in the very near future.
Mm. Another thing that I haven't mentioned is that you can. I also added some filters here. If you are only interested in, I don't know, checking on the adjectives, for instance, among those 300 most biased words, you can just filter them by selecting them here. Great. This is just a way of filtering all this huge quantity of words.
Super.
Yep. So let's jump to the next one. Let me select some of those so I can show you. Let's jump to the next part. So those are word distributions. That gives you a certain idea of how biased or how skewed the distributions of bias and frequency are in both data sets towards females and towards males. Okay, so what you can see here is just, for instance, I have bias selected, and I'm selecting, I'm only looking at the 25 more biased words for each of the genders, right? Female, for each gender, female and male. For instance, here you can also click here, and it will get painted in the table, etc. This thing about highlighting is just so you can follow a word and where it falls within the distribution. So just trying to help analyzing the data. You can also select frequency. You order for frequency. You can select all words as well. This is a little bit messy, but you can zoom in by scrolling in, and then you can explore the words. So what I wanted to show you, let's ignore the names. Just, for instance, you see that they follow a certain common distribution of frequency, even if the words are biased, okay, are selected by bias. But when you go to bias, in this data set, you see that here we have like a stronger curve a little bit. So it's more relevant for female than male. That shows you that there are more stronger bias words towards female than towards male. It's just another way of analyzing things. Then it can also give you information about the community that you're working. Okay, the next one, it's also explained, everything is explained here. The next one is talking about polarity. So working a little bit more on the sentiment. We classified the sentiment in 7 different categories: positive, slightly positive, strongly positive, neutral, negative, etc., etc. I'm explaining everything here based on the sentiment value. Do you remember the sentiment value that we showed on the table? So this is the same information but organized in categories, all right? So here what we see is if you select, I don't know, let's say the 100 most biased words for each gender, you see that, for instance, female or male, for instance, have more positive when compared to female that only have slightly positive. So this is a way of analyzing the inherent polarity of the most biased words towards each gender. Okay, you can also press ignore neutrals, and it basically removes the neutral part, which is most of the words. Since the sentiment was analyzed without considering the context, it's only the inherent polarity of each word. Most of them are neutral. You can also remove the neutral so you can get a clearer picture of what you're seeing, right? This is really interesting to see if, for instance, just imagine a community that women or men were mostly tagged with negative words, that meaning that the most biased words towards each community were mostly negative. That means that this community is in heavy risk of being discriminated. If all the words that are often used in the same context as this community are negative, that means that people are using specifically those words to define people from that community that could be dangerous. So that's why we decided to include this part of bias polarity analysis. You will see there are some other data sets that have stronger biases and stronger differences between female and male.
Xavi, can I just ask a quick question?
Sure.
If you click on ignore neutrals so that we see the neutrals.
Yep.
Is there anything in general that we can take that we would find when we're using some aspect of when we're looking at language and bias to have the kind of the distribution where we see a relatively high percentage of neutral language? Just insofar as 92 or 89 point.
That's what. So one way. So that the way this sentiment analysis tool works is you give it a sentence, right?
Yes.
And it gives you a number of how positive or how negative a sentence is. The thing is that we're working with word embeddings, with the first version of word embeddings, and we don't have a sentence for each of the words. We only work with the words.
Yeah.
So that's why some of the words that we're using, especially nouns, they don't have a negative connotations by themselves, but only if they are in a context.
Yeah.
We don't have the context here. That's why most of the words are neutrals.
Yes.
Yeah. Yeah, this obviously can be improved because we have the data set. We can explore the whole data set and see all the sentences in which this word appears, if it's positive or negative, right?
Right.
But
that doesn't, I mean, just also to be clear, just because there's a high percentage of neutral doesn't mean that bias is not a problem.
Exactly. Yeah. I mean, it's a completely different. So negative bias are like are dangerous, I'd say, but even neutral bias are might also be dangerous. As you saw, for instance, for female, let me show you again. Most of the most biased words, such as oral by itself doesn't have a sentiment or negative connotation, but oral in this context, in which all the other words are related with sexual activities, you know that oral means like the act of giving oral, right? Lesbians by themselves, they don't have negative connotations, but when you use this word only to objectification, that's another example. This is not a negative word by itself. It doesn't have a negative sentiment, only if you apply it into a certain context, right?
Yeah.
That's why you should not only take a look at the sentiment. Sentiment is something that gives you extra information about the words that you saw on the first table.
And is it fair to say that we are using these different methods to give a richer, more comprehensive, complex understanding of bias and discrimination, which you wouldn't necessarily get if you just use one of these methods?
Definitely, yes. One thing that we realized when working on this project is just that there are these so many different dimensions that play a role in discrimination. It's not only the word, it's the context, it's the meaning of the word in that context, it's the way this word is used in that community, and along, etc.
Yeah. So like what I would say to students that are thinking about their assessment is there's a lot that you could do just describing what kinds of insights each approaches to a single data set gives you that we've been covering here. And I think that's important to keep in mind. And that's something that you could do.
Exactly, yes. Yes, definitely.
Because each one is giving us different kinds of information, and also we can build by cross-referencing different approaches.
Definitely, yes. And it's also super interesting comparing different data sets. So for instance, opening a new tab here and opening a new data set and place one data set on one part of the screen and the other one on the other side, and then compare them. This is a really interesting exercise as well. So, okay, so after exploring the sentiment or the polarity, we're jumping to the word embedding space. As you already know, we're using word embeddings to identify words that fall closer and that are biased towards genders. Here, we were trying to show you what the embedding space looks like. This is just keep in mind that these embeddings are trained on 300 dimensions. So what you're seeing here are only 2 dimensions. It's like a simplification of the 300 dimensions. But those 2 dimensions were specifically selected in order to try to make words that mean similar things fall together. So as you see, for instance, you have Tinder here, you have Bumble here. Both of those are apps, and they are close in this space, right? You see also chick, brunette, babe, hottie, gal. This is for female bias words. You see them on top here. So girlfriend and GF are super close together, which makes sense because they mean the same thing, and along, etc. So this is not the real. What I wanted to say is this is not the real word embedding space. This is a simplification, so we can visualize it in 2 dimensions, right? We used TSNE, which is a technique that I think I have a link around here. And we also used Davis, which is a visualization library that we slightly modified in order to show this. By moving this scroll over here, we're gonna see more words. You see the number? I'm showing 184 words in the embedding space. I created this slider in order to kind of clean a little bit the words, so you can hover on them and along, etc. If you hover on them, you get data, which is the same data that was shown in the first table at the beginning. So for male, yes.
So Xavi, if you hover over any given word,
Yes.
then we can. Okay,
Yeah.
here we go. So it's showing the same elements that were in the first approach that you highlighted, that was in a kind of a scrolling table form. And maybe, because I'm just trying to cue the students to think about, so this is taking similar data that you've analyzed, but this is actually doing a simplified visualization of what this looks like in a kind of a high vector space. Is that correct?
Yeah, that was the idea. Yeah.
And so is it fair to then say that each word that's embedded in this high dimensional space is it's a visual representation or an embedding of the elements that are captured when you scroll over that, and it's about kind of, it's giving some kind of complex relationship on the distribution of those words. Is that right?
Yeah, exactly. Yeah, exactly. So it's just that all the data that we're using, the way we select the most biased words is by exploiting the similarity between high dimensional vectors of word embeddings, right? This is just a simplification or a way to let students understand how a little bit how this works, right? Because you see that words that are close together mean that they have similar meanings. So by just imagine if you put all these words that we show here, I will show you later, but if you put this in and compare it with a female or male concept, you will see that some words fall closer to male concept and some words fall closer to female concept. And those set of words is what we select as gender biased words.
Right.
So exploiting this kind of two-dimensional space is the way we find, let's say, which words are biased towards female and which words are biased towards male.
Right. Because in a sense, because maybe in an abstract way, what this is helping us to see is the sort of the power and the ability of more complex computational processes when we have large data sets, because it allows us to kind of compare and take a snapshot of relations between many things at once, in a sense.
Definitely. The position of these words here in this specific image do not mean much. It's just that words, the only thing that you can use from here is that words that are closer together mean similar things. And this is what you can extract from here. Mean similar things as understood by the trained model. Yeah. So when we give all this data to the model kind of decides which words mean similar things. So if you have watched Tom's video, Tom explains this part as well. And this is for all the students. But basically, this is the only information that you can see here. But I think it's really interesting to see how it actually works. Yeah. Like the distribution of words. Just to be clear, all those words that I show here, the 300 words that I show here for male, are the same words that you can see in this table. Everything works using the words that you can see in this table. So it just shows different information about the same words. So when you load the data set, everything changes. So based on this idea of because this is a little bit messy when you select a lot of words, based on this idea of similar words, words that fall closer, we create what we call the concepts. Because exploring the biases word by word, it might be a little bit difficult, especially if you're working with thousands of words. Here we only work with 300 just to show it. But what we create is what we call the concept embedding space. Everything is explained here. Once again, basically what we're doing is grouping words that are closer in the embedding space together. We group them because we think they talk about the same concept. For instance, here you see a concept. Let's see, I don't know, for instance, this one. Bimbos, babes, sluts, skanks, gals, hotties, sluts. So those are clusters that define, I don't know, specific, I don't want to talk about it.
Yeah.
But there are concepts of
Trigger
words that
warning
are
for
related
everybody.
together. Yeah, I don't want to, yeah, I'll let the students explore it, it's fine.
Yeah, yeah.
Okay, so basically if you scroll over all those circles, those circles are clusters. The bigger the circles, the more frequent the words in the cluster are. So that means that the words clustered inside this circle are more frequent in the dataset, are used more often by the community. The smaller it is, the less important the cluster is. For instance, there's a cluster here, this contains coffee, dinner, drinks, which also makes sense to be clustered together. As you can see, one thing that is super clear here is you see that the words related with woman or biased woman biased concepts are on the bottom right of the image, and biased male bias concepts are on the top left of the image, right? This we didn't actually predefine this. This is just gathering the same information that we were showing here using this simplification method separates the data so clearly that you see that there actually exists a bias in the embedding space. So if you place the concept female in this image, it will probably fall close to this point. So those clusters are decided to be female related, female biased. And if you place the concept male in this image, it will probably fall close to this space. So that's why those clusters are also defined as male bias concepts. So what I want to show is that this difference between the words used towards female and towards male, it's not something that we made up. It's something that it's actually trained and learned by the model. So those biases are embedded in the model, and this is a good representation of how those biases, how these different words are split apart in the model space. Just keep in mind that this is not exactly the model space, this is a simplification, but still it gives you an idea of how the model is differentiating those words, right? Yeah, some other things, you can select the clusters using this button here, because it might be difficult to select them here. We clustered all those words in 40 clusters for male and 40 clusters for female. That doesn't mean that all the clusters make a lot of sense, because we forced this number in order to cluster the words. There's more a technical discussion, but it's fine. And yeah, this is another way of exploring how the system groups words that mean similar things together and how it compares between the two genders that we're studying in this visualization tool. Yep.
Cool.
So I think this is the last part. I'm not sure if you have any other question, Mark, or yeah.
I think that, you know, when I'm looking at this, to me, what's really interesting, and I think what could be useful for the students, and I think what we both encourage them to do, is to spend a bit of time to play with the different data sets, to try to look at the relations between the different kinds of approaches that are laid out for the data sets. To think about the ways in which we can gain even more information or understanding by looking across these different approaches, and maybe by, as you've been doing, sort of thinking about, you know, what does this show, what kind of information does this give us as opposed to, you know.
Yeah, to the other implementation. Let me show you, let me try something. First, let's select Google News, which is supposed to be more neutral. You see that, for instance, the words more biased towards female and towards male have changed. They are not as strongly biased as the previous ones. You will see as well that there are not as much negative words for female. There are some for male, but not as much as in the red pill data set. So the biases change in this community. Yep. And this is the exercise, right? If you select all of them, let me see. you see that most of them are neutral.
Yep.
Right?
Higher percentage of neutral.
Exactly. And for instance, positive is really strong for females in that sense. Not really strong because this is relative, right? Not really strong because it only represents a 2.5%, but it's strongly compared for relatively strong when compared with males. Okay. And yeah, it's just that, for instance, look at this. This is also interesting. This doesn't directly mean anything, but you see that the concepts are more kind of sparse in the embedding space, and this not as much as a clear separation as it was with the red pill.
Yeah.
So yeah, this also tells you some information that there are not as strong biases as in the red pill, which is this information can also be observed. Sorry to move you around in this bias. Right? So the biases, okay, maybe here is clear. Those biases are not as strong as the red pill, I would say. I haven't compared them, honestly, but they should not, even if they are strong, they are not as negative as in the red pill. Yeah. So this, I think this is really interesting for like to be exploring. Let me just the last one. I think it was gender critical, which is I'm not gonna do the students' work. I just want to show you something. So, for instance, look at gender critical. If we ignore the neutrals, there is a huge difference between the polarity of the words used, biased towards male and biased towards female. Towards female is often considered strong, and towards male is mostly negative.
So if I can just pause you for a second and just say, like, to me, one of the things that I would take out of this is it's important that we think about, we don't have just a single or simple understanding of what bias means insofar as this is a kind of a very female positive site, but not just female positive, one that's critically responding to millennia of patriarchy.
Exactly.
So within that context, maybe what we're seeing as much as anything else is a bias that reveals a critical language towards patriarchy, right? So this is part of why it's important to understand the context of your data set and the kind of the cultural norms that are embedded. But then we need to think about the next step, because what happens when this is used in a straightforward way within a training data set, it's going to result in a kind of a bias in an automated decision-making system, which is something additional to and different from that kind of cultural context.
Definitely. Yeah. You're completely right. So I think I'm done here, Mark. I don't know if you want to add anything else, or do you have any other questions to add here?
So this section is done then, in other words?
Yep.
Yeah.
Exactly.
I think we can sort the details, and I will do that in terms of a formal announcement on Keats, in terms of thinking about a kind of a follow-up Q&A, because, and maybe in order to do that, I'll give the students some advice around how they might want to approach this for their assessments. And once I've done that, then we can think about a virtual Q&A, but we can do those details later. I guess the only last thing is that we should just look at the last couple of slides. I don't need to take over now. Maybe you can just still, if we go back to, I think there's only a couple more, right?
I think so. Let me go.
Yeah.
So yeah, so this is once again the link, and something really important. The bias is obtained, is defined when comparing two different concepts. So I cannot say what is the bias towards female. I need to say why is the bias towards female when compared with male. This is something that I forgot to mention, that this is really important. Nice that I had this slide. And yeah, so this is the last part.
So this section is what we would have done if we had been able to run our workshop this Thursday at the Science Gallery London, because they have a major exhibition on right now that's looking at the idea of gender, but also and it's called Reshaping the Binary, I believe. And
Yeah.
so if you think about it, everything that we've covered up until now, the bias and any discrimination is based on a very clear binary distinction of male and female, right? So there's that clear binary categorization, right, of gender.
Definitely,
The idea of this exhibition, and it's trying to address kind of, you know, cultural changes for many, wherein there's a sense of a kind of a non-binary gender position, right? So in other words, we can't have that simple male-female, but we need male-female, you know, non-binary, and then that puts things on a spectrum. That changes because as we see here, you know, the discrimination and bias were made to compare two concepts, right? And that's what we saw in the kind of the word embeddings. But do you want to go to just to the next?
Sorry.
So if we're breaking the binary, and if for many, because there are many people increasingly who refuse, don't feel that they are reflected in a male or female gender position. So that requires a more complex kind of categorization, right? If we want to try to capture that complexity or plurality of gender. So that raises a whole set of new challenges, right, Xavi? If you're trying to look at bias and discrimination in terms of sort of for non-binary people, let's say.
Yeah, exactly. I mean, as I just said, for instance, here in our approach, we were just comparing male with female with using a set of words that were defined by other researchers. But there's not only male or female, male or female. So how can we approach this problem? How can we computationally identify what are the biases and discrimination like towards those other like gender fluid groups, for instance, right? So this is a really interesting problem as well.
So yeah, I was just going to say, so if this is something that's particularly of interest to you, then it's something that definitely you could follow up on your project. If less so, then perhaps not. But these are things that we can follow up with questions and answers. So obviously we can't entertain any questions and answers right now because Xavi and I are just recording this from our homes. But as I said, I'm going to follow up with that. Did you have any final comments, Xavi, that you wanted to?
I think everything is clear. Just make sure to watch all the videos.
Yeah.
I know I've been insisting really too much, but I think it's fine. I think I'm done. On my part, it's fine.
Fantastic. Okay. Well, Xavi, I want to thank you because that was super informative. The platform and it's fantastic. I think it's something that I suspect a number of the students are going to want to do their project for this class on the basis of this. And I think it's really, it's very user-friendly and highly intuitive and informative. So thank you very much.
Thanks, Mark. Thanks. I really appreciate it. Yeah.
Fantastic. Okay, students, this has been a long video now. So Xavi, can you stop the recording or should I? And we'll say goodbye. And we'll clumsily figure out.
I cannot stop sharing my screen, Mark.
Is it me?
I need to stop sharing it, but it moved away from my screen. Okay, let me see.
Okay.
Are you still seeing my screen?
I still see your screen.
Okay.
Okay.